Welcome to Inventor Camp Professor. I'm Sydney, your Inventor Camp Professor, with one of hundreds of online video tutorials available free at www.inventorcamp.com 24 hours a day, 7 days a week. In this session, we'll be showing you the new way we handle post-processors by using the machine ID. Well, what exactly is machine ID? Well, if we look at our previous versions, when we had our post-processors, they were compiled of two separate files. They were compiled of a file called GPP and another file called MAC. What we've done now is taken the MAC file and split that into two separate files. One called VMID, which is the machine ID file, and another one called PRP. If I were to double-click on VMID, you can see that this window opens up, and you can see all of the options that we have here that are on the machine itself. And it's a lot more graphic, a lot easier to be understood. For instance, we have the name of the machine itself, all different types of options, devices, submachines. All of this is in VMID, and any extra type of devices that we need on the machine itself. Now, we'll get back to this in a moment. Now, we also have, as I've said, a file called PRP. In the PRP file, we have all of the rest of the information that we need, for example, for the G code, what number we want to start in, whether we want to have compensation, everything that is determined by the G code fit for the controller of this particular machine. Now, let's go back into our VMID, our machine ID file, and let's take a look exactly what we have here now. If we take a look in our left-hand column, you can see that we have all of the main options that we need here for our machine ID. If we start with the first one actually shows us the name of the machine itself. If we take a look in our right-hand column, this gives us all the different types of information that we may need. For instance, the catalog number for the machine, your company name, the model if we want to put that in, controller, operation type, whether it's a milling machine or a lathe, and the post process as well, which GPP file this is going to be using. If we want to make a change over here, we just simply click on the field, and as you can see, we have a drop-down menu, and you can pick any of the post processors that you have inside your GPP folder. Next, we have our options. In the options, we have such things as dwell, whether they exist or not. You can put a value in over here if necessary. We have machine stops, optional stops, for example. We can click over here and keep it at on or none if it's non-existent. Machine power, all of these are open over here. Doors open, close as well. We even have chip conveyor, whether it's clockwise or counterclockwise, or non-existent, or just on and off, whatever options is necessary for the chip conveyor. All of these are over here in the options. Next, we have the devices. The devices show us exactly what devices we have in the machine. In this particular case, we have the turret and the table. Now, if we continue on down in the devices, we can first go to the turret. In the turret, you can see that we have first the name of the device. In this particular case, as I've mentioned, it's called the turret. That's exactly what I have over here. We have the minimum and maximum spin rate over here. We have the home reference in this particular case as shown over here. Coordinate system, turret type. In this particular case, the turret type is a spindle, where it can also be either linear or rotary. We have our main pivot points. All of this information is over here. Also the tool change time in seconds. And we even have the number of axes. The number of axes in this particular case is 3 as shown over here. Now, if we were to click on the plus next to the turret, we see over here that we have our options of the turret. the dwell time, all of these options over here. Coolant, if we have coolant over here, we can put that on over here as well. We have our coordinate system, as we have our X, Y, and Z vectors as shown over here and their position. And if we go to our next thing, we have our stations. In the stations, you can see that we have the adapter type. And we can also click on the plus in the stations. We have here in this particular case station 1, and clicking on the plus over here, showing us the coordinate system for the stations itself. We also have inside the turret, we have here the actual axis itself, showing us that we have 3 axes, the X, Y, and Z, all being linear. If I were to click on the plus on the axis, you can actually see the axes over here. If I were to click on X, you can see we have the X-axis as shown over here, the name, being linear as shown over here. The axis vector for X being shown over here, where 1, 0, 0 means it's moving in the X direction. It's 0 point, also showing us that it can move simultaneous. And the minimum and maximum limit of the machine. For example, I can change this to be minus 800 for the X direction in the minus direction, and the maximum being 800 as well. We have the interpolation step, the minimum that each step will go, in this particular case 1 micron. We have also the rapid feed for our table as well, as shown over here, and the minimum and maximum feed as used in actual machining feed. Now, if we were to go into our Z, for example, we can see we have the exact same options over here, except over here the axis vector is in the Z direction as shown over here. This also, in this particular case, is simultaneous. Now, if I wanted to add another axis, that wouldn't be a problem over here at all. I can just right-click on axis and add an axis. I can give it the axis name. I can call it A, for example. I can have this as a rotary table, as shown over here. And you can see now it's given the name A. And I can put all the relevant information needed over here. Don't need it, right-click, and just delete it as well. If I wanted to add a device, no problem. I have all the different types of devices over here, and I can simply add it by dragging it into this area. So for example, if I wanted to add, say, a device called a part catcher, all I have to do is hold the left mouse down on part catcher and just drag it to devices. As you can see, the part catcher has now been added to the devices itself with all the different types of options that it may need for that. If I wanted to add, for example, a custom device, just drag custom device and put that over here as well and give a name to the custom device as well. For example, some kind of a fixture that I may have on this particular machine itself. Another important option that we have in Machine ID is submachine. Now, let's take a look at this diagram for a moment. As you can see, we have over here a diagram of a mill turn machine, in this particular case, an Integrex. If we take a look, we have a front spindle over here, our main spindle and our sub spindle or our back spindle. We have one turret on top, and we have another turret on the bottom. Now, what the submachines are, it's the actual combinations that can be made with the turrets and the spindles. For example, we can have one combination of the upper turret and the main spindle. This one over here, the upper turret with the main spindle. Or we can have the upper turret with the back spindle, the sub spindle. We can also have the same thing with our lower turret with the front spindle, the main spindle, or the back spindle or the sub spindle. And as we can see over here in the machine ID, we have here the table and turret as shown over here. Now let's take a look at the machine ID itself. If we take a look at the machine ID, in this particular case I'll be showing you the Integrex 200. We have here, of course, the name of the machine, And over here we have the sub-machines. Now, in this particular case, the sub-machines are made up of three different options. We have our lower turret, made up of our lower turret and the table. We have our first combination made up of our head and table. And we have our upper back made up of our head and back spindle. If we wanted to add another submachine, all we have to do is right-click on submachines and add another submachine as well. Now, let's take a look on top over here, and we have the option in Open of actually seeing our machine simulation to see exactly how everything over here is lined up. Now, as you see over here, we have our machine itself, as shown over here in the diagram. And as you can see, we also have our different devices on the machine itself. For example, we have our spindle in the back. We have our main turret with the spindle inside of it, with the spindle inside of it over here as well. We have our bottom turret as shown over here. We also have the main spindle as it can move also in the Y direction and moving obviously in the Z direction as well. The bottom turret here shown moving in the Z direction. We also have the direction of the turret as shown over here, complete control, and of course we have the spin of the main turret. Now we can have all the different combinations that I've mentioned before. We can have the main turret working with the back spindle or the front spindle as shown over here. And we can also have the bottom turret working with the different spindles as well. Now, if I were to start a new milling operation, for example, you can see that over here we have, before we even choose our geometry, the option of choosing the different submachines. And as you can see over here, we have the list of the submachines exactly the way it appeared in our machine ID. For more Inventor Can Professor tutorials, please go to our website, www.inventorcam.com, and look under the tab called Inventor Can Professor. Thank you for joining us on Inventor Can Professor. Take care and have a nice day.